Alright, my dear children, now we solve next problem, that is problem number 2, and this is also a problem based on measuring the momentum, wavelength, the mass of the photon. Okay, so let's solve problem number 2, and it says that the energy of a photon, again we are dealing with photons, the energy of a photon is 42 eV. So this eV, children, is also the unit of energy. This is the smallest unit of energy, and this energy unit is called electron volt. See, energy is also measured by the smallest unit, that is called electron volt. Okay, so energy of photon is given. Energy of photon, which is marked by letter E, that is given 42 electron volt. EV means electron volt. Look at this. So this is the smallest unit. But what I do, I convert this EV, electron volt, into joule. And there is a relation between which 1 electron volt is always equals to 1.6 into 10 minus 19 joule. See, this part you have learned in class 10 also. Electron volt, which is the smallest unit of energy, is equals to 1.6 in minus 19 joule. So what I do, I convert electron volt to joule, so I multiply this factor. So I write down now this E equals to 42 into, so it will be 1.6 into minus 19 joule. Okay, now you can multiply these two values. You can multiply with the help of calculator. Okay, you get approximately 67.2 into 10 to the minus 19 joule. So the energy I am writing in terms of joule, and that is 67.2 into the minus 19 joule. Now from this, what we need to calculate? The momentum of photon. The momentum of photon. Now how to calculate the momentum when energy is given? Yes, we use one of the relation. Okay, so to calculate the momentum, okay, I use the formula, that is, therefore I write down the momentum of photon. The first part I am calculating is the momentum of photon. Okay, and there is a formula. Momentum is also expressed by E by C. In terms of energy, momentum equals to E by C. Because this C is the speed of photon. And you know what is the speed of photon? Always 3 into 10 power 8. Because photon are the light particles. So E is 67.2 into minus 19. C means 3 into 10 power 8. Okay, now we can do the division out. 67.2, if I divide by 3, you get approximately 22.4. How much? 22.4 into 10 power minus 19, and my plus 8, if I take in the numerator, is minus 8. So it's coming now as 22.4 into 10 power minus, now minus 19 minus 8, if you add, is minus 27. Okay, but children, this is the momentum that we are calculating, and this momentum you see is in two digit, but I write the answer in single digit. So what I do, I shift this decimal to one number front. So if you shift one number front decimal, if there is a negative power, then this power decreases by 1. This is a simple rule. Okay, so I can write this as 2.24 also into 10 to the power. The power decreases by 1 means minus 27 become minus 26. And the unit is kg meter per second. So we calculate the first part of the answer. The momentum of photon is 2.24 into 10 minus 26 kg meter per second. Now the next thing that we need to calculate is the wavelength of the photon. Wavelength also we can calculate. So how to calculate the wavelength? Now wavelength, to calculate wavelength, we know momentum, we calculate the momentum just now. Okay, we know energy. So I can use any of the formula. So better I use the formula of momentum of photon in terms of wavelength. In this question, children, your value of Planck's constant is not given, but we take that value of Planck's constant as h equals to 6.63 into 10 to the power minus 34 joule second. So children, we take the value of Planck's constant as 6.63 into 10 minus 34 joule second. Okay, now to calculate the wavelength of photon, you know there is a formula, P equals to h by lambda. Children, look at this formula, because this formula I am going to use in the next chapter. Okay, matter wave also. Okay, so P equals to h lambda means lambda equals to h by P, just making lambda as a subject. So let me substitute the value of h, 6.63 into 10 to the minus 34 whole divided by P means how much this much? 2.24 into 10 to the minus 26. Yes, we can simplify this. But children, we calculate the wavelength basically in the unit called Armstrong. So we keep the standard unit of wavelength as Armstrong. Now let me divide 6.63 by 2.24. You can use calculator and divide, you get approximately 2.959. So I am writing in 3 decimal place 2.959 into 10 to the power minus 34 is already in the numerator, minus 26 if I take in the numerator, plus 26. Okay, so it will be how much now? 2.959 into 10 to the power minus 34 minus 26 means minus 8. So this wavelength that we are measuring is in the power of minus 8, and the unit we usually express is in meter. But as I said already, children, we can write the wavelength in Armstrong also. So in order to write the wavelength, that from meter to Armstrong there is a relation. Just look at it. 1 Armstrong is equivalent to 10 to the minus 10 meter. Look at the power. Armstrong, smallest unit than meter. That is 1 Armstrong equals to minus 10 meter. But this power is minus 8. So I have to make this minus 8 as minus 10. So what I do, I shift this decimal 2 number right. If there is a negative power and if you shift 2 number right to decimal, then this power will increase by 2. So just opposite to the previous part. So I can write this as 295.9. See, shifting 2 decimal right, it will tend to a minus 10. Yes. So power increased by minus 10. Minus 2, sorry. Which means this is nothing but 1 Armstrong. Okay, so look at it now. Lambda now is 295.9 and the unit is Armstrong. So what is the wavelength of that photon? That is 295.9 Armstrong. So this is the second part of the answer. Now we come to the third part of the answer. In the third part of the question, it says that you have to find 2 masses. One is the rest mass, one is the kinetic mass. So children, you know, I have already explained what is the rest mass of the photon? 0. So rest mass of the photon is 0. So rest mass of what? Photon is 0. Because photon can never remain at rest. Photon is the light particle, always travel with a speed. So rest mass is 0. But the next mass that we may measure is called the kinetic mass. So yes, kinetic mass is there. And we measure the kinetic mass of photon. So kinetic mass is basically expressed by letter m. So m can be written by in terms of any of the expression. Okay, but let me use this one. E by c square. Because E equals to mc square, so m equals to E by c square. Because we know the energy, we know the speed. So what is the energy of photon that we have already calculated? 67.2 into 10 to the minus 19. I am putting directly the value. Speed of photon 3 into 10 to the power 8 with whole square. Okay, so 67.2 into 10 to the minus 19 divided by, now let me open the bracket. 3 square means 9. 10 to the power 8 2s are what? 16. Now 67.2, if I divide by 9, you can use the calculator, you get approximately 7.467. So I am writing in 3 decimal place. Okay, into 10 to the power minus 19. Now minus plus 16 if I take in a numerator is minus 16. Simple exponent. So let me just write again 7.467 into 10 to the power minus, okay, minus 9. 19 minus 16, minus 9, 19 minus 16 means minus 35. So look at the unit, minus 35. 10 to the power minus 35, very, very small. But this value can be even round up as, now 467 in 1 decimal place can be written as 5. So what is the kinetic mass of the photon? 7.5 into 10 to the power minus 35 and the unit is kg. Look at the mass of photon, the kinetic mass of photon, which is 7.5 into 10 to the minus 35 kg, which is even smaller than the mass of the electron. You know, electron is the smallest particle of the atom. Okay, the fundamental particle of the atom, subatomic particle of atom. Okay, which has a mass, but the mass of photon is even much smaller than the mass of the electron, which is 7.5 into minus 35 kg. So this is the solution I have done for question number 2. So we have other numericals to solve, okay, and that we do continue in the next videos. Thank you.